Okay, here we go. This is the last quiz of Chapter 2, which is also the last quiz of Unit 1. Unit 1 covered both Chapter 1 and 2, which was the number system. And I apologize if I sound a little tired. I'm doing this video at the end of the day. Usually I do the videos in the mornings, but I'm redoing these videos. So I sound a little bit tired. It's because I am tired. But here we go. This Chapter 2.4 is covering both multiplying and dividing rational numbers. We are okay if you use a calculator on these, but a lot of times students are going home and they don't have the same calculators they're used to using in the classroom. We're using the TI-80XS. They're nice because they have fraction buttons on them. They're not nice because they sort of make our students depend on a calculator rather than just thinking about fractions logically. Okay. So we're just going to go through each question. I'm going to make up an example. And just don't forget, negative times a positive is always a negative. And let me just do an example. Just with integers, we knew a negative times a positive was always going to be a negative. Okay. Or a positive times a negative was always going to be equal to a negative. So these rules, these patterns, still apply. In fact, that's the same with division. A negative divided by a positive is a negative, and a positive divided by a negative is a negative. So as we've taught these before, we hope that this is something that sticks with you, because you're going to need to know this in the 8th grade, in the 9th grade, 10th, 11th, and 12th, and even into college. For the rest of your life, you're working with negatives. So please do this carefully. And all right. So, as you're looking at this, I'm just going to make up one. I'll just do like 2/7 times a negative 1, I don't know, 4th, whatever. Okay. I like fractions and I like multiplying fractions, and here's why. Unlike adding and subtracting, when you multiply fractions, you don't need a common denominator. All you do is you multiply them straight across. Multiply them straight across. And so 2 times 1 is 2. 7 times 4 is 28. And it's a positive times a negative. It's a negative. This would be the answer for mine. It does ask you to reduce it or put it in simplest form, which means that if it's improper, it wants you to mix, and if it's non-reduced, it wants you to reduce it. So I could reduce this. This 2 goes into both 28 and 2 evenly. 2 divided by 2 is 1, and 28 divided by 2 is going to be 14. This would be my answer in reduced form with my example, but of course it's not your example. You'll have to solve for your own on this one. Okay. With decimals, multiplying decimals gets a little bit trickier. I think dividing decimals is the trickiest. This is one thing that I think, to be honest with you, a calculator will do for us. And any 9-digit calculator is functionable with decimals, and that's kind of one of the reasons why we're okay, especially with decimals, that students use calculators. So I'm just going to make one up, and then we'll talk about what's happening by hand if you want to. But so let's say I'm multiplying 2 decimals, and so maybe I can just say, I don't know, 5.2 times, where's the times, times like 4.3, okay? So that does the multiplication for us, which is great. All you have to do is think about this and think, okay, this is a negative times a negative. And what is a negative times a negative? Always. Multiplication and division follow the same pattern. A negative times a negative, the opposite of the opposite, is always going to give you a positive answer. Okay? Now if you're looking at this by hand, maybe I'll just make up one by hand. So like a negative 6.2, no, that's the same one. So like a negative 1.4 multiplied by negative 2.1 or whatever. I'm just kind of making this up. Well, when I do long multiplication, which I'm happy to show you, and I'll show you one time only. Again, calculator kind of does the work for us. But 1.4 multiplied by 2.1. This is, you could line it up one way or the other. We're multiplying it. Just know that the answer is going to be positive because negative times negative is a positive. So whatever the answer is, it's going to be positive. You're working with each group, and for now you can almost ignore the decimals. 1 times 4 is 1. 1 times 1 is 1. So far, so good. Okay. 2 times 4. Oof. Actually, I've got to put a space here because this space right here, maybe I'll do a different color. This space right here is now being represented with this. So 2, it's almost like saying 20 times 4. So 20 times 4 is 80, really, which is 2 times 4 is 8. And then 2 times 1 is 2. Then I can add these together. And I'm going to get, let's see, 1 plus 0 is 1. 9 plus 1 is 8 plus 1 is 9. And then 2 plus nothing is 2. Now here's the cool part about decimals. Now I can look at the decimals and I think I've got 2 numbers that are beyond the decimal. This is going to tell me how many decimal places from here I move. 1, 2. So that's going to be 2.91. And I can check that on my calculator. So 1.4 times 2.1. So 1.4 times 2.1. Yeah, it's the same thing. Same thing. I got the same exact number. So there you go. Anyway, this is kind of how you do it by hand. But most of you have, a dollar store calculator, I like to call them, that will do decimals for you. So you can use those for that. Okay, question number 3, division. Okay, division is, similar. Again, we use a calculator for this one. Yeah, you absolutely could. And maybe I'll make up another one. So instead of saying, 4.13 divided by negative 4.5. Just think of this. Remember, what is a positive divided by a negative? You're always going to get a negative result here. Okay, so has to be, and really, if you're looking at the answers, it's actually pretty obvious which answer it's going to be without even solving this. Okay, because think about how many times 4.5 can go into 41. About how many times? Okay, you think about, it's going to be somewhere, and the answer is going to be negative. So it's really kind of almost, without even having to do the math, pretty a given. Okay, so maybe I won't even have to bother talking about this one. But division, if you want to see decimal division longhand, this is something we've actually chosen not to reteach. The 6th grade and the 5th grade and even up to the 4th grade has taught dividing by decimals. We don't have time in our curriculum to reteach it, but we can make one up real fast. So we say something like this. We could say, I'll make something hopefully a little bit easier, like 10.2. Okay, divided by, let's say, 1.3. Okay. And I don't know, let me think, I don't know if that's going to work out, but we'll see. And let's say even a negative. So we know that the answer is going to be negative. And when we're setting up long division, this is how it's going to work. All you have to do is move the decimal place on the outside inward one time, or as many times as it takes so that you're now working with a whole number. But if you move a decimal, you have to move the other decimals inward as well. So really, I'm going to set this back up over here. So really, it's going to be 13 into 102. Or in other words, 1.3 divided by, 10.2 divided by 1.3 is the same answer as 102 divided by 13. So now we just go, all right, how many times can 13 go into 1? 0. 10? 0. 102? Well, let's see. 102 divided by 13. That's 7 whole times. So 7 times. And 7 times 13 is 91. So 7 times 13 is 91. Bring it down. 1, 1. Okay, 13 into 110. Probably 7 times again. Oops, 110 divided by 13. You know, oh, 8 times, yay, so 8. So this time, 8 times 13, 104. And we can keep going, probably for a very long time. This is actually going to be a repeating decimal of some kind. Oh, we did forget something though, didn't we? We forgot the decimals here. So this is going to be 7 let's see, how many times 13? Let's go one more. So let's go 80 divided by 13, 6 times, and 6 times 13, 78, and then I get a 2 here, and I could keep going for a long time, but I'm going to stop. I'm just going to say, you know what, what's a couple of 100,000ths among friends? That would be my answer, and of course, don't forget, it was in positive divided by negative, so the answer should be negative here. This is how you do a long division with decimals. I'm showing this to you just for those rare occasions when a student goes, how do you do that again? But mostly a 9-digit calculator is a really good friend, and there's very few careers out there where a boss is going to make you solve this by hand. They're just going to say, no, use the program. Okay, fractions on the other hand, dividing by fractions, this is actually very nice. I'll set up an example. Remember, a negative divided by negative is automatically a positive, okay? So negative divided by negative is a positive. You should have that down. You should know that at least. And I'll do so I'll say 3/4, negative 3/4 divided by a negative, I don't know, I'll just say 1/2. Okay? So this is kind of saying how many times does 1/2 go into 3/4? If you had 3/4 and you cut it, it's going to be like, you know, 1 and something, like a little bit more than 1. And if it's negative divided by negative, so you know it's going to be a positive, that has to be the answer. But what's happening here, and you can rewrite things like this. I want to show you this. This is a negative 3/4 divided by a negative 1/2. Okay. The reason I'm showing you this is because I want students to understand that a fraction over a fraction, or a fraction within a fraction, is just division. All this is a negative 3/4 divided by a negative 1/2. So when you're looking at your example over here, you might be able to think of it the same way. Now when we're working with division, we can do something with numbers in the denominator. We can do what we call the reciprocal. We can find the reciprocal. The reciprocal is literally switching the top and the bottom. Now the reason we can do this has to do with the fact that, well, let's look at an example up here. The reason this actually works. 3 is just an integer, but we can write it as a fraction of 3/1. Okay. So when we're looking at 3/1, we can think of that as a fraction. Okay, I'm going to do a different example. I'm going to think, okay, let's look at 1/2. 1/2, we understand, this is like saying 1 divided by 2. Alright, so 1 divided by 2. You can think of it that way. And every integer can be written. So I was talking about how 3 can be written as 3/1. So every integer can be written as a fraction. So we could rewrite 1/2 as 1/1 divided by 2/1. Right? And here's what's happening. When you look at 1/1 divided by 2/1, think about the reciprocal of the denominator for a second. Now, if I reciprocate the denominator and then bring it to the numerator, bring it up to the numerator. So if I reciprocate it, meaning find the, like switch it around, swap them, That's finding the reciprocal. So 1/2 is the reciprocal of 2 over 1. And I bring it up, what I can get here then is 1 over 1 multiplied by 1/2, the reciprocal of 2. And 1 times 1, we can just multiply straight across, that's 1. And 1 times 2, multiply straight across, that's just 2. So in other words, we went from 1/2 to 1/2. This mathematically is a why we can find the reciprocal. So now when I'm looking at this example over here, let me bring you back to this one. When I'm looking at this example right here, dividing by 1/2 is going to be the same thing as taking -3/4 and multiplying by the reciprocal of a -1/2, which is going to be a -2 over 1. And now all we did was take the division and turn it into a multiplication. So what's 3 times 2? That's 6. What's 4 times 1? That's 4. It's a negative times a negative, which is positive, so it's going to be positive 6/4. And let's reduce to a 3/2, and let's reduce even further and say that's 1 and 1/2. So in other words, 1/2 goes into 3/4 one whole time plus another half. This is how division of fractions works, and it's really not super complicated. Understanding why it works is a little bit more tricky, and this probably wasn't the best explanation, but you can divide fractions by multiplying by the reciprocal of the second fraction. That's how it works, and it's kind of nice that way because multiplying fractions is super easy. So, all right, and the last question has to do with a division again. The only thing I'm going to say about this one is remember how when you're dividing, you can multiply by the reciprocal. Only when you do the reciprocal and when you multiply fractions and they're mixed, the first thing you'll have to do is convert them to improper. So we can do this a quick example. So -2 and 3/4 divided by a -3 and 1/5, whatever. So the first thing I'm going to do is find the improper. So 4 times 2 is 8 plus 3 is 9, 10, 11. So this is -11/4. And I'm going to be dividing that by 5 times 3 is 15 plus 1 is 16, so 16/5, a negative. Don't forget that part. Now, dividing by fractions can be rewritten as multiplying by the reciprocal. So let's say this is a -11/4, now multiplied by the reciprocal of a -16/5 is a -5/16. So dividing by this fraction is going to be the same as multiplying by the reciprocal. Now, this is just multiplication straight across. 11 times 5, 55. 4 times 16, oh, well, let's see, that's 24 plus 40, so 64. And a negative times a negative is a positive, so I am done. Can I reduce? I don't think so. Off the top of my head, I don't think so. That's my example. Of course, you'll want to do your own over here. Just think about it. And lastly, imagine you got two numbers that are very close to each other, almost the same. And any number divided by itself is going to be 1, so any number divided by something near itself has to be approximately 1, like very close to 1. So think about that. That might help out a little bit. It might at least eliminate a few of your responses for you. Hopefully this is helpful. Hope you enjoyed, and have a good day.